The second step of hydraulic fracturing involving water is the mixing of chemicals with the water to produce hydraulic fracturing fluid. This fluid is mostly water. It may be more than 10% sand, and it can then contain a variety of chemicals classified as acids, scale inhibitors, corrosion inhibitors, biocides, surfactant, friction reducers, and other groups. Which chemicals are used? Well, this can vary over time, and so early in the fracture, different chemicals might be used than later. And it can vary depending on the geologic formation from which natural gas is being extracted. So nitrogen gas may compose more than a quarter of the hydraulic fracturing fluid when working with under pressure geologic formations, but not in shale formations. The chemicals can also vary depending on the drilling company, the community, and a host of other variables. And so therefore, while ethylene glycol can be used, it has been reported in 46% of the disclosures, so that 54% of the disclosures did not report using ethylene glycol. Naphthalene used in 19% of disclosures, trimethylbenzene at 13%, and so the chemicals can vary from well to well. Since reporting is often voluntary, many chemicals are not disclosed. This could be, as some argue, needed to protect industries whose particular combination of hydraulic fracturing fluids might then be used by competing companies. Others would argue this makes it more difficult to perhaps hold companies accountable if there is a leak, because it is not known which chemicals should be tested for, because the ones used are not fully known. Accidental spills do occur, but the effects of these would vary depending on the volume of the chemical which was spilled, the specific chemical which was spilled, the proximity to groundwater, whether this contaminates the drinking water of the surrounding area, and the effectiveness of the response in cleaning up the spill.